I first got into electronics actually by modding Nerf guns almost 10 years ago. So I thought, what better than a return to where I started by modding one of the most iconic electronic Nerf guns ever made. The Nerf Stryfe is pretty unremarkable in its stock form, but it can be upgraded to be pretty high performance, going from its base around 60 feet per second shooting velocity to almost double that. So just with regards to the internals, for this build you'll need a flywheel cage, 2 flywheels, 2 Valkyrie motors, a LiPo, a male XT60 connector, and a 21A micro switch. So the first thing we want to do is take it apart, and I bought this second hand from eBay, and clearly the original owner had these batteries in for a while because they'd all leaked out and left the entire battery tray crusty, so I had to clean all that up first. Next you want to take out the 14 Phillips screws holding the shell of the Stryfe together so that we can take a good look at the inside. And basically we want to keep the rev switch, the trigger and the thrower arm assembly as well as the mag release. And we can get rid of all the original wiring and the flywheel systems, including desoldering the thermistor from the battery terminal, because we're going to replace those anyway. And there are a few other little orange pieces here and there that are used to house the wires, which we can keep too, but they're not really necessary. For now though, we can take out all of the internals and keep them safe, because we're going to be preparing the shell for painting. Now, I'm definitely not an expert in the modding aesthetics department, but I would recommend taking your time with the sanding, covering all the little nooks and crannies and corners and everything. First, going over the whole shell with a rough 120 or 150 grit sandpaper, and then go over everything again with a finer sandpaper, maybe something like a 220 grit, to smooth it out. And make sure you clean away all the dust and shavings with a microfiber cloth or compressed air, or even wash it down if you need to. So now for the painting part. So make sure to do this in a very well ventilated area and use a respirator mask if possible. So after the shell and the necessary parts are sanded and ready, we can start painting. So I used a matte grey primer and I put on 3 coats to make sure it was properly covered. Make sure that you don't spray from too close like I did a few times, and do not keep that spray paint can in one area too long, otherwise the paint's going to pool up and it's not going to look good. I had a very specific paint scheme in mind, somewhat inspired by this image. So I used masking tape to cover the areas that I needed to for painting, but this is where you can get creative and you can do whatever you want really. That's the beauty of modding. So next I applied 3 coats of a glossy red spray paint, and then I reapplied the masking tape to the areas I just painted, and I filled in the rest with 2 coats of a metallic silver spray paint. Now that the parts are ready and painted, we can start with the electronics. So first I opened up the battery tray, which was of course designed for 4 AA batteries. We can strip out everything in that battery compartment so we can make room for our LiPo. And I ended up using a mixture of wire cutters, pliers and my Dremel tool to sand down the insides. Make sure to wear eye protection. The last thing you want is to be blinded by a rogue piece of material flying out of the battery compartment. Now we can get to our upgraded flywheel assembly, inserting our 2 Valkyrie motors into the cage, and make sure to get the orientation right as well. You can use the red dots to help you figure out which way round each motor should be. Where the top motor should be situated so the red dot is farther away from where the dart will exit, and the bottom one is in the opposite direction where the red dot is closer to the end where the dart will exit from. To wire up the motors, we'll need to solder a wire to each motor and then solder them together. I split the exposed copper into 2 and then wound them together before soldering them so they're physically and chemically bonded. This is what Draconical calls NASA grade soldering. We also want to solder a 3rd wire to the join we just made, and this wire needs to be longer because we're going to run it through the body of the gun, and then we're going to protect the join using heat shrink. Make sure to slip on the heat shrink before making the 3rd join, otherwise if you make all 3 soldering joins you won't be able to then put the heat shrink on, obviously. Now we want to create the same configuration for the negative terminal. Notice how I'm positioning the wires so that they face upwards. That's going to make it easier to feed them through when we place the flywheel assembly back into the shell. I made sure to test the motors using my power supply just to see if it was working. And now that we know it is, we can put the cage back into the shell, and I'm going to put the actual flywheels itself onto the motors. Now we can run the positive and negative wires through the channels that are already made in the shell of the gun, and we can secure the orange cover back on it as well. We can take our positive wire and take it down to the rev switch, and along the way we can also cut out a small channel to make it easier to pass the wire through. So now you want to connect our red wire to the normally open pin, which is furthest away from the clicky lever switch, and then you want to solder another wire to the common pin. You'd ideally want to mount this to a switch plate which has been 3D printed, but instead I just cut out the space to place the switch, and then I hot glued it in place, making sure that the switch can get pushed in when you reinsert and press the rev switch. Now we want to start reinserting some of our components, such as the mag release and the trigger with the thrower arm. And you can see that I'll take the time to cut out a few more channels to pass the wires through, just to make sure that they really stay out of the way of our thrower arm and our moving parts. We can now also thread through our red and black positive and negative wires, which will connect to the battery through the hole that's created when we desoldered the thermistor. Now we want to solder our red and black positive and negative wires to the positive and negative terminals of the XT60 connector. I find that it can be safer and helps avoid melting if we plug into an adapter as you're doing it. And you want to cover these joints with heat shrink, but as you might be able to see, I forgot to cover one of them with heat shrink, and then I later used electrical tape, but do use 2 heat shrinks if possible. We can now connect up our LiPo and place it inside of the battery compartment. And I used a specially made 3D printed extended battery compartment, which I ordered from UK Nerf War, which was produced by Fancy Impact Blasters, which allowed me to comfortably house the LiPo. It was originally orange as I ordered it, and I gave it the same sanding and paint job as I did the rest of the blaster. I used some black acrylic paint to dry brush the silver parts of the gun to make it look more weathered, and then I also added some fake scratches where the paint would have chipped off, and I used silver rub and buff to achieve that effect. I also found some old 3D printed worker parts, like a barrel extender and a stock, and I gave it the same sanding, painting and weathering treatment as I did the rest of the blaster. So here we have the fully completed final product, which has been given aesthetic and functional enhancement. Now let's take it out to the shooting range and see how it performs. As you can see, we've achieved a significantly faster shooting velocity from this stock performance, and at the very least I like to think it looks cooler than when it started. Thanks for watching, I hope you enjoyed the video, and I'll see you guys next time.